So welcome back to our UVA series. So in this video, I will trying to explain how to solve the problem in UVA. So in this video, we are going to solve these questions. 11044, searching for Nessy. So in short of this long story, it is something like in a hole, it has a mystical monster or something. Then they are trying to reduce the number of sensors used to detect the monster. So given a grid of m row and m columns representing the log, n m is more than and equals to 0 and less than and equals to 10,000. Find the minimum number of s of the sonar beams you must put in the square such that you can control your position in the grid with the following conditions. One sonar occupies one position in the grid, so the sonar beams contain its own cell and the contiguous cell. Border cells do not need to be controlled because Nessy cannot hide there. So for example, you put here. So if you have control over these cells. So for here, yes, it puts here, then you control over these cells. It puts here, then you control over these cells. So X represents a sonar and the shaded cell controlled by the sonar beams. So the last figure gives a solution. Well, this is not really a solution. So the first line of the input contains an integer t indicating the number of test cases. For each case, there is a number with two numbers separated by a blank. The range, that is the size of the grid. So we are given a grid, then we are required to find the minimum numbers of sonar that can cover the grid. So the questions itself is quite complicated, but in fact the solution is quite easy. So let's create an Excel. Let's say if we have such blocks. So I try to create some colors. So these are the blocks we want to find. So in order to get the minimum numbers of sonar, we will try to maximize the efficiency of the sonar can cover. So we are not putting the controller at the corner because it only can cover 3 cells. So if we put here, then it can cover 8 cells and including itself. So we should put a middle first. So okay, so this is the first one and the second one. X. So I fulfill this is X. So for here we have no choice, but we are trying to put here. But putting here also is also a reasonable case. So this doesn't really matter. So the next one. So in fact, if you can identify the trend, we are trying to break the cells into trees, the size of a tree, like this, and like this. So for the questions, let's say if I have 6, then I should divide it by 3 for the x-axis and another division by 3 for the y-axis. So we multiply them together, then we will get the answer. So for cases like something like this, where our length is not the multiple of 3, we have no choice but we get the floor of the value when divided by 3. So, okay, maybe you can just code it here. It's not that hard. So what is the input? So the input states we have the first number is the number in the test cases that we are going to get. So our test case count equals to line. Alright. So I look through them. So given any test cases, I just look through them. Even 3, then I just look for 3 times. Okay, now we will use string tokenizer. So we will read the next line, and we extract the size of the X. Next token. Okay. Next, we will calculate the number of sonar needed for the x-axis. So we need to change it to double first, so that we can get the ceiling value. So we have 3 dot ceiling. So we convert it back to integer. So this is the okay done. So we have gotten the value for both axes, and we just print out x needed times y needed. Okay, so we run it, we copy here, paste. So the solution is as simple as this. Done. So we are done. And then we need to check the bound, but the bound is quite small, so it is under 10,000. So our max value for x needed will be 3334. Y needed will be 3334. So if we multiply them up, it is still less than 10 power of 8. It should be 10 power of 9. So this for this range, integer is still acceptable. So that's why I'm using integer to solve this problem. So if the input is larger, then we need to consider to use big integer or use long to solve it. Otherwise, it will cause overflow because the maximum case will exceed the value of integer. So that is it for this question. It's pretty easy. So see you in the next episode. Okay, so see you.